So the next speaker is Professor Carlos Banyon, who is an architect specialization in digital design and advanced manufacturing with large building structures. So in particular, the product by Carlos have won many awards. And I would like to simply highlight the most recent one. He has won the most prestigious design award in Singapore that we known as Singapore President Design Award. And this award was started a few years back with his collaborator in Zhejiang University, Professor Tao Jiang from the Civil Engineering and Architecture. So his presentation is interesting. The title is Innovation in Sustainable Architecture Through Digital Manufacturing and Design. So without further ado, let's welcome Carlos. Carlos, please.
Thank you very much for the introduction and welcome everyone. Just want to make sure that the slides are clear to be seen. Okay?
Yes.
Okay, good. So welcome everyone. Well, I mean, in today's presentation, I'm going to talk about like a number of things, and particularly how can we build more resource efficient structures in our built environment. And the question comes because, well, industry creates so much waste, like 20 million tons every year. And then additive manufacturing can contribute to lower the levels of energy in production up to 21%. So in SUTD, and in particular in the Architectural Intelligence Research Lab that I lead, we implement those technologies with a positive impact in sustainability. And we pose research questions. We aim to solve critical problems relevant to our built environment. So today I'm presenting like 10 questions that we asked and we tried to answer. The first one was, can we build an entire space out of packaging waste? So it's a big problem because packaging waste management moves 80 million tons a year, and most of it is, well, part of it is recycled, but most of it is landfilled. So we started a research collaboration with DB Schenker, the logistic company in Singapore, to build an architectural space out of their waste. So the design brief was completely open. It's like, well, we have this waste, what can you do, right? So the question was quite open-ended, and that's why in SUTD we use creative design to address those new challenges that we have nowadays. So we work with wooden pallets, with plastic bottles, to polystyrene foam and cardboard to create furniture and spaces. So the first one was to design a low chair using foam by using CNC technology that is able to create a smooth shape and to be connected. To produce the chair. The second one is a cardboard coffee table. We use another like laser cutting machine, the large scale one, to cut the pieces and to integrate them in a seamless design. Inside there's a concealed structure of aluminum, and the shape is extremely smooth and sturdy. So we created like very well finished furniture using extremely cheap material and basically just cardboard. So the next one is a wood pallet dining table. So we figure out using 3D modeling how to create a table that was sturdy enough and big enough for the employees of DB Schenker to be used as a dining table. But most importantly, we address a big challenge here, which is the plastic waste. We created domes out of plastic bottles, and to do that, we collected bottles from the sea and collected bottles from their wastage to produce filament to be used to print the tiles of the chandelier. So what you see here is the process, and how we crush the bottles. Here is how the bottles are crushed into flakes. Those flakes are dried, and those flakes are turned into filament. So that filament is the one used to print each of the tiles that were assembled by our team and the DB Schenker employees, creating awareness and creating a large-scale design out of smaller tiles. But also we explore larger scale construction using larger panels like this one. So using as well the bottles collected from DB Schenker, we were able to print with our robotic arm larger panels like 1.5 meter each to create a larger chandelier. As you can see here is the process of printing in our lab. So the result is a fantastic space where each of the items is actually created with upcycling the waste of the company. So it's fast in Singapore and will be open by end of September. Will be also featured in the Archifest Festival in next October. Next, can we scale the system to complex structures using biopolymer 3D printed parts? So we created a parametric design, which is something that goes really well with 3D printing, to design each of the 3,500 tiles that constitutes the main time capsule pavilion at SUTD. So we created this ornamental surface by printing each of them using a 3D printing farm. So many printers printing the tiles that were assembled by researchers and students. So it's an exploration on how to use 3D printing for cladding for decorative panels to create large-scale surfaces. And this allows us to create details that are special and completely new, not using standard parts, but bespoke ones. This design was awarded with the Singapore Good Design in 2020 and is still in the SUTD main lobby and will be there for the next 10 years. Next, how can we utilize more organic matter in our built environment? So to that question, basically we wanted to respond with a material which is bamboo, which is a renewable, fast-growing and powerful carbon sink. And we combine new technologies to use the material in a novel way. So in a very simple manner, we use a 2D scanner to scan the edges of the bamboo that are registered in our script. So what you see here is each of the sections of the bamboo ends that are integrated in our script, and we print a bespoke connector that fits perfectly the bamboo poles. So this is part of the family of connectors that were automatically designed and 3D printed. And we use FDM, which is the entry-level technology in 3D printing. So the cost was very low. We used biopolymer plastic. So we created a very affordable construction system that was tested in our facilities. Tensile tests were actually performing very well. And then we developed it as well in the fabrication lab. We tested it before we implemented on site. The pavilion was built with our research team in less than a day and stood there for 3 months. And you see the novel detailing, like the connection of the roof with the nodes and very, very intricate structure that is a result of combining digital design and 3D printing. This design got the Singapore Design Award in 2018 and also became found stage for the Singapore Design Festival, created a landmark in the backyard of the shop houses in Tanjong Pagar district in Singapore. We use this technology to create disaster relief biodegradable low construction structures. So this was showcased in Archifest. It's a rapid deployable structure, extremely low cost, lightweight, that can cover about 15 square meters that could be used for disaster relief. 4, can we build a more resource efficient and 100% biodegradable farming system building on our research on bamboo? So we started a collaboration with City Development Limited in Singapore to print vertical gardens 100% biodegradable. These trouts are 3D printed with bioplastic and the poles are bamboo poles. Inside the poles, there are the ducts for the water pipes. We engaged local farmers to help us with the initiative. And we assembled the first prototype that is actually functional in CDL facilities at the moment. So this is the first of its kind, was finalist of the 3D Pioneers Challenge last month. And we're pushing the system forward to be integrated in new developments in Singapore, like condos and HDPs. Next, the next question for us was like, why should we use 3D printing in high performance architectural structures? And to that question, we have three reasons. The first one is because 3D printing produces zero wastage in fabrication, which is a crucial issue nowadays. Second, because it can produce radical new aesthetics, completely redefining the way that we conceive design. And third, unlocks full freeform designs. So we targeted the connection instead of the full object. So we look at the existing systems that are standardized and basically the continuity is not achieved, and we work towards a future system where continuity is granted and freeform is enabled. With the reference of the past work from Arab on this topology optimization node, we started a research in 2015 on how to print the nodes to make them more efficient and to enable for more complex structures in the built environment. We generated our script to create any possible shape out of tetrahedrons that was discretized into bars and nodes. I'm going to show just a few slides of the 3D model that we use to produce this kind of network structure. So we only print the parts that are needed to be printed. So the nodes that are the complex ones are 3D printed, where the bars are standard. So we didn't want to disrupt the industry. We want to use standard components where still are needed, and we print where it's actually necessary. So we combine 3D printing with digital design. So this parametric script is able to create any shape, address the nodes and bars, create a draft geometry for the nodes, and also estimate the cost in a very early stage. So that allows us to really know every single inch of the structure that we are designing at a concept level. The geometry is smoothened, the elements are created, oriented, and each of them are 3D printed. We know properties of each of them, the size, dimensions, structural capacity, and even the cost. Depends on the geometry of them, the cost could be more significant. Depending on the angle of the bars, maybe the node get longer and then the cost get higher. So that was a way for us to optimize the cost, moving the nodes to place them in the right place to reduce the total amount of material. Here you see the first family of the nodes. This is the first version of our idea of space frames. Ones were printed in nylon, others were printed in stainless steel. The assembly was done with the help of our SUTD students. We always get them involved in our research projects, and this was the outcome of it that was presented in 2015, and this was the beginning of our journey in lightweight structures in SUTD. 6. Can we integrate systems inside our structures? Well, since we use 3D printing, we have space inside. So that was the question, can we run electronics, can we run water pipes inside the structural members? So we optimized our script to create a complex geometry that allows for the cables to run through and to insert more than 50,000 LEDs inside the structure. Here you see the family of the 3D printed nodes, and this is the system that was implemented in the structure. It was tested in the Fab Lab, assembled, and taken to the site. Our students help lifting the structure. Always we get our students involved because they can feel the weight, the construction process, the design process, so they are involved in each of the steps. So you can see here how the structure is able to be handled by 12 students to be placed in the final two boards. The result was this. So the pavilion stayed in Marina Bay for 1 month and was interacting with people, responding to the presence of people, was changing the light. It was actually a nice art installation that allows us to test structural ideas and concepts in 3D printing. That was awarded the Rethinking the Future Award in 2020. We conducted some tests after the festival was gone, so we knew the boundaries of the structure, and at some point we made the structure collapse. And this is a problem in Singapore, and not only in Singapore, everywhere in the world. When you have an event, an art piece, you need to dismantle it, and sometimes you just dump it. So we wanted to give a second life to our pavilion. So after the structure was collapsed, we recovered the nodes, we cut the bars, and then we created a new chandelier for the National Design Center. We created, by 3D printing, in a short period of time, we developed new light bulbs that were shining inwardly to the chandelier to create a light effect in the museum. 7. Could we reduce the use of material while maximizing the structural performance? And to that question, we responded designing a table that uses 3D printing in stainless steel. So that was a collaboration with the D&D lab, and we tried to address a structural challenge that initially was actually quite extreme. Like, can we transfer a load of 200 kg into 3 small points? So the usable surface of the tabletop is 22,000 centimeters, and the contact surface is only 18. So the ratio is quite extreme. So the way that we addressed the transfer of the loads was using a very thin mesh of stainless steel bars and nodes that was optimized with our algorithm with a total weight of only 15 kg. So each of the nodes was parametrically designed and fabricated. Here you see a 3D model of it, developing details of connection. This is a prototype of one of the legs. And to connect the bars and the nodes, we developed a system to add threads to the pegs to screw with the right hand and left hand the bars so they come in together into one node. This is the assembly system and how we put the structure together. This is the result. As you can see here, the bars are extremely thin, 6 millimeters in diameter, but can take more than 200 kg. That award was awarded, that design was awarded the German Design Award in 2020. You can see here the ratio between the span and the connection with the ground. Then we explore the idea of merging AI and 3D printing to design high performance components. A project in collaboration with the ZAU University allows us to develop optimized strategies to place the material where only is needed, creating iterations in a really short period of time. It was actually developed in collaboration with VoxelJet Germany that made a case study out of this project. It was casted in bronze, and this is the result, what the legs were polished. And the resulting geometry is basically driven by the forces and the boundary conditions of the element. The 3 legs are different because the tabletop is irregular and the forces are acting in different directions. And we got as well international recognition recently for this furniture that is the beginning of a new direction for us to optimize the structural components, even in the space frames that we are working on. Nine, could an entire space be built producing zero wastage in its construction? And this is the Mesh Pavilion that is the result of 3 years of close collaboration between SUTD, ZAU, and Gardens by the Bay. We always look at nature as a source of inspiration. Mesh's very lightweight structure replicates a neural network, its complexity and efficiency. The form is a representation of a traditional Chinese lantern created for the Gardens by the Bay's Mid-Autumn Festival. Our goal was to create as light a structure as possible by spreading the forces into very thin elements throughout 3D printing. It drastically reduces the use of materials and the entire structure's embodied carbon footprint.
For the user, the idea is that the structure matters less. It is about the enjoyment of the surroundings. Behind the outward simplicity of the Mesh Pavilion, there's a complex and robust structure delivering the experience. We designed a whole new construction system that allows for more adaptable and freeform designs as compared to more traditional space frames that are limited by standardized nodes, bars, and angles. Using 3D printing in stainless steel, each of its bespoke joints is computationally generated, integrating a concealed connection system. That simplifies dramatically the construction sequence, so connecting a node to a bar is akin to assembling one big piece of IKEA furniture. In a sense, we have made an ultra-high performance structure accessible to more people that allows for rapid deployments. What's also great is we have actually managed to achieve zero wastage material in its construction. Mesh has set the precedent not just for Singapore, but truly for the world on the possibilities of 3D printing technologies in our built environment. This small pavilion has punched above its weight and already gotten the world's attention. We are ready to scale the system to design bridges, long-span shelters, or multi-story spaces to bring across our confidence in this technology and blaze a path for the future of construction in Singapore.
And last, will our future buildings be lighter, more adaptive, and efficient? And that's one of the current projects we're working on, which is to scale the Mesh project into a facade system that allows for vertical farming. And this is an ongoing collaboration with Netatech that will be displayed by end of the year. We are targeting adding to existing buildings, not just starting from scratch, but how to adapt new structures into existing buildings so that they can perform better, and in this case, to grow vegetables in their facades while creating spaces that are interesting. So that's the last project that I showed today. It's an overview of what we do in SUDD in terms of research and architectural design with 3D printing. So any questions, you can always email air@sudd.edu.sg. And also we released recently a book on 3D printing architecture, workflows, applications, and trends, where you can go deeper in each of the projects that have been showcased today or others that were not presented. So here's the QR code in case you want to learn more about the book. So thank you very much.
Yeah, thank you, Carlos. It's a very, very exciting talk. I personally always very refreshing when I look at your structures, pictures, and the message they send to the world that the sustainability is important. So allow me, there are actually 3 questions on the Slidos. They are kind of related, but let me maybe pick 2 of them. Okay. So the first one is basically asking, in comparison with digital transformation, right? So we know how the IT transform our life. What is your view in sustainable transformation for architect?
Okay, that's a good one. Yeah, I mean, well, the speed of transformation in architectural sector is traditionally quite slow, I would say. I mean, based on my experience or what I know from the field. So most of the buildings in our cities still use very traditional means in their designs and construction. And I think it's not gonna change dramatically in the next coming years. But I think what the change that's happening right now is that our entire society is more aware of the need of gearing towards more sustainable ways of utilizing resources. And it's affecting all kind of industries, right? So it's just not just architecture, but also energy harvesting, food production, travel and construction. So we are really experiencing an exciting revolution in the built environment sector that it will take some time to become mainstream. But I think that the path has been set already. So the agents involved, like the government institutions, developers, designers, material manufacturers, even educators, we are exploring sustainable and more resource-efficient strategies. And even the current pandemic has accelerated the transformation. So I really see, in particular, Singapore carrying the flag of sustainable construction, and it's in the agenda. So the transformation is going to happen, maybe not at the same pace that other industries are doing, but I see a big change happening in the next decade for sure. The way that we build and we design is going to be completely different, and that's really exciting.
Okay, thank you. So the second question is, we see that you have used very intensively 3D printing in your research for your architectural design. So the question is, how does 3D printing play an enabling role in the future phase of architects?
Yeah, we're trying to answer that question almost every day, because 3D printing allows for more freedom for design, right? And it affects all the stages. It affects the concept design. So when you are designing, thinking of 3D printing as a method to manufacture, some constraints are released. You don't need to go for standardized parts. You can create bespoke details. The shapes are more freeform. And then you need to engage parametric design in a concept in a concept level. So I think now architects are changing, moving to a more digital approach even at the beginning, because digital tools allow you to address that complexity in an earlier stage. Also, I think, as I said, 3D printing allows for bespoke components. So when it comes to construction of the details and developing the one-to-one parts, there's a new approach to it. So even the way that we detail, that was more traditional in the past, trying to use more standardized parts, now is more creative. So it redefines even the way that we sent our design to be fabricated. In the past, we need to produce all the drawings, floor plans, elevations, details, so forth. Now, potentially a file that can be sent to the manufacturer and just printed and brought to the site, or even printed inside. So it's changing all the stages of the architectural process, and I think for us it's also very exciting because it's a technology that allows to meet the circularity goals. We can only use material where it's needed, and we can even use materials that comes from upcycled parts. Then in many ways it's a game changer.
Okay, so thank you, Carlos, for sharing all the interesting products and also the building structure that you fabricate. So thanks again for your time. Thank you, Carlos.
Thanks for your kind invitation. Thank you very much.
Bye-bye.